matrix, any square matrix, A is equal to Aij of order n by n is said to be symmetric if A is equal to A transpose. That means Aij is equal to Aj for all I comma j. For all I comma j. So rows ni columns ni rows ga convert chestam. Note the number of non-trivial entries. The number of non-trivial entries in the set of R, symmetric matrices of order n is equal to dash. And notice that we already discussed symmetric antundi kabatti. So this is A11, A12 dash dash A1n, A21, A22 dash dash A2n, up to so on, AN1, AN2 dash dash ANn. Symmetric antundi kabatti ఇది ఈక్వల్ ఈ రెండు ఈక్వల్. సో ప్రిన్సిపల్ డయాగోనల్ కంటే కింద ఉన్న ఎలిమెంట్స్ అన్ని డిపెండింగ్ ఆన్ అప్పర్ ట్రయాంగులర్ ఎంట్రీస్ కదా. సో ఇవన్నీ తీసేయచ్చు. రిమైనింగ్ ఎన్ని ఉన్నాయి సార్? ప్రిన్సిపల్ డయాగోనల్ ఎన్ని ఎలిమెంట్స్ ఉంటాయి, సూపర్ డయాగోనల్ n-1 ఎలిమెంట్స్ ఉంటాయి, దానిపైన n-2 అప్ టు దిస్ వన్ వన్స్. సో టోటల్ నెంబర్ ఆఫ్ ఎంట్రీస్ ఎన్ని ఉన్నాయి సార్? 1 + 2 + 3 + up to n entries. So total number of entries are n into n plus 1 by 2. So therefore the total number of non-trivial entries are linearly dependent entries in the symmetric matrix is equal to n into n plus 1 by 2. Next one, definition. A square matrix A is equal to Aij of n by n is said to be skew symmetric if A is equal to minus of A transpose. If A is equal to minus of A transpose, that means Aij is equal to minus of Aj. This is true for every I comma j. This is true for every I comma j. Therefore, now the number of non-trivial entries in the set of R skew symmetric matrices SSM is equal to any, sir?
n-1 into n by 2.
So n into n-1 by 2. ఎందుకు? This is one
Diagonal 0.
Diagonal element 0.
So Aij is equal to minus Aj. This is true for every I and j. So if I is equal to j, Aii is equal to minus Aii. So which implies that 2 into Aii is equal to 0. This implies Aii is equal to 0. That means the principal diagonal entries in the skew symmetric matrix is zeros. Therefore, the diagonal entries in the skew symmetric matrix are 0. And therefore, the trace of skew symmetric matrix is always 0. The trace of skew symmetric matrix is always 0. Problem. Let capital A is equal to 1001 with the 2 by 2 matrix over the field Z2. Then A is dash. Options are skew symmetric, option B symmetric, option C scalar, option D identity.
Skew symmetric.
Sir?
Skew symmetric.
Skew symmetric. Symmetric. Sir, in the over the field Z2, the matrix A satisfies all these properties. Simple, this is symmetric since A transpose equal to A, so therefore A is symmetric. Right, sir? And what about A transpose? A transpose equal to 1 0 0 1, so which is also equal to minus 1 0 0 minus 1. Avuna? Enduku 1 is congruous to minus 1 with respect to modulo 2, sir. Or minus 1 is congruous to 1 modulo 2 this day 1 and minus 1 both are same. So 1 equal to minus 1 with respect to modulo 2. So therefore, which can be written as minus of 1 0 0 1. So therefore, which is equal to minus A. Therefore, A is skew symmetric. And also A is a scalar, sir, where K is equal to 1. It is a scalar matrix and also identity. So A is all. Next one. So therefore A is skew symmetric, scalar, identity. Properties. A and B are symmetric matrices. Symmetric, and K is any scalar. Then number 1, Ka is also symmetric. K is also symmetric where K is any scalar. Number 2, A plus B is also symmetric. Enduku A plus B whole transpose equal to A transpose plus B transpose. If A and B are symmetric, A transpose equal to A and B transpose equal to B. So A plus B whole transpose equal to A plus B. And number 3, AB. What is AB? AB whole transpose and AB whole transpose equal to B transpose A transpose, where B transpose equal to B, A transpose equal to S. If it is equal to symmetric కావాలంటే this is equal to AB కావాలి. And that means A and B are coming to each other, then it is symmetric. So if AB is equal to BA, then AB is symmetric. AB is symmetric over if AB is equal to minus BA, that means anti-commute. Then the matrix AB is skew symmetric. Matrix AB is skew symmetric. So the product of two symmetric matrices are may be symmetric or not. If it is commutative, A and B are commutative to each other, then it is symmetric. If A and B are anti-commute, then it is skew symmetric. Next one. A power n. So all integer powers of A of a symmetric matrix is always symmetric. Is also symmetric irrespective of n. For every n belongs to A. For every n belongs to Z plus. Number 5. If P is an n by n matrix and A is an n by n symmetric matrix, then P transpose AP is also symmetric. Is also symmetric. Consider P transpose AP whole transpose. So which is equal to ABC whole transpose equal to C transpose, right? C transpose, B transpose, and A transpose. So P transpose, A transpose, P transpose, O transpose, which is equal to P transpose, A transpose. Since A is a symmetric, so A transpose equal to A, and P transpose, O transpose is P. So P transpose AP, O transpose equal to P transpose AP. So therefore, this one is symmetric. Next one, number 2. If A and B are skew symmetric and K is any scalar, then K into A is also skew symmetric. And sum of two skew symmetric matrices is also skew symmetric. Assume that A plus B whole transpose equal to A transpose plus B transpose, but A transpose equal to minus A, B transpose equal to minus B, so which is equal to minus of A plus B. So therefore A plus B is also skew symmetric. And number 3, P transpose AP, similar to P is an any n by n matrix, is also skew symmetric. Next one, AB transpose. And this is fine. Number 4. AB whole transpose. AB whole transpose equal to B transpose into A transpose. So B transpose is nothing but minus B side. A transpose equal to minus A. So minus into minus getting cancels, then you will get BA side. So if BA, so if AB is equal to BA, then the product AB is symmetric side. And if AB is equal to minus BA, then AB is skew symmetric. So product of two skew symmetric matrices are maybe skew symmetric or not. If it is anti-commute, then it is skew symmetric. If it is commutative, then it is symmetric. And integer powers of a power n, where a is a skew symmetric matrix, is skew symmetric if n is odd, and it is symmetric if n is even. Suppose assume that if n is equal to n is an even number, so n is even, and assume that 2 into m. Consider a power n. So a power n whole transpose. So a power n whole transpose equal to a power 2m whole transpose. So which is equal to a transpose whole power 2m, where a is skew symmetric, therefore it is minus a, right? Minus a whole power 2m. So which is equal to minus 1 whole power 2m into a power 2m. So which is equal to a power 2m. Since 2m is an even number, so minus 1 power even number is equal to 1. So therefore, which is equal to a power n. So therefore, a power n whole transpose equal to a power n. So therefore, a power n is symmetric. And if n is equal to 2m plus 1, then a power n whole transpose equal to a power a transpose whole power 2m plus 1 direct rational. So which is equal to minus a whole power 2m plus 1. So which is equal to minus 1 whole power 2m plus 1 into a power 2m plus 1. So minus 1 power odd number is equal to minus. So minus of a power 2m plus 1 is a power n. So therefore a power n whole transpose equal to minus a power n, which implies that a power n is skew symmetric whenever n is odd number. Next one. If A is any square matrix, then A transpose and A transpose A are always symmetric. Matrices, irrespective of A. And third, consider A transpose whole transpose. So which is equal to AB whole transpose equal to B transpose into A transpose. So A transpose whole transpose into A transpose. So which is equal to A into A transpose. Therefore, A transpose whole transpose equal to A into A transpose. Therefore, A transpose is symmetric. And A transpose A whole transpose equal to A transpose into A transpose whole transpose, which is equal to A transpose A. So which implies A transpose A is also symmetric. Next one. This is 1 and this is 2. This is A. If A is any square matrix, then A plus A transpose and A minus A transpose are symmetric and skew symmetric respectively. So if A is any square matrix, then A plus A transpose is always symmetric, and A minus A transpose is always skew symmetric. Then proof అవసరం అనుకుంటున్నా. Next, see every square matrix A can be expressed as sum of symmetric and skew symmetric matrices. Skew symmetric matrices. That means A can be written as A is equal to 1 by 2 into A plus A transpose plus 1 by 2 A minus A transpose. ఒక్కొక్కసారి అడుగుతున్నాను సార్, అక్కడక్కడ అడుగుతున్నాం. ఇఫ్ గివెన్ ఒక మ్యాట్రిక్స్ ఇచ్చి దెన్ ఫైండ్ ది సిమెట్రిక్ పార్ట్ అండ్ స్క్యూ సిమెట్రిక్ పార్ట్ అంటుంది సార్. సో దిస్ వన్ ఈస్ సిమెట్రిక్ పార్ట్ and this one is skew symmetric parts. మనకు జేఎల్డీఎల్ కూడా అడిగారు సార్ దీనిపైన, ఈవెన్ సిఎస్ఎల్ కూడా అడిగినట్టున్నాడు. నెక్స్ట్ వన్ problem. Suppose assume that let A is equal to 0 minus 2 minus 2 0 minus 2 0 and x is equal to 1 2. Then x transpose Ax is equal to dash. ఎంత వస్తుంది సార్? Another one, let A is equal to 0 minus 2 minus 3 2 0 minus 4 minus 3 4 0 in minus 2 also in plus 2 minus 3 4 0 and capital X equal to 2022 2023 2024. Then X transpose Ax equal to dash. Here A is a symmetric, skew symmetric, sir.
Yes.
A is a skew symmetric. So if A is a skew symmetric, then if X is in any column matrix, then X transpose Ax is always equal to 0. It's always equal to 0. If X is in column matrix and A is any skew symmetric matrix, then X transpose Ax is always equal to 0. Irrespective of X. And that means if A is skew symmetric, and capital X is any column matrix, then X transpose Ax is also skew symmetric, and X transpose Ax should be 0. Should be 0. Next one. Next one. If A and B are symmetric, if A and B are symmetric, then AB plus BA, AB plus BA, and AB plus BA is a symmetric matrix, and AB minus BA, AB minus BA is skew symmetric. Is skew symmetric. And go. Consider AB plus BA whole transpose. By definition, A plus B whole transpose equal to A transpose plus B transpose. Right, sir? So AB whole transpose equal to B transpose A transpose plus A transpose B transpose. So which is equal to, where B transpose is B, A transpose is A, right? Plus AB. But sum of matrices satisfies the commutative property. So BA plus AB is equal to AB plus BA. Therefore, AB plus BA whole transpose equal to AB plus BA. Therefore, AB plus BA is symmetric. Okay. And AB minus BA? AB minus BA whole transpose equal to similar sir, ఇక్కడ మైనస్ వస్తుంది, ఇక్కడ నేనేం రాస్తున్నా, AB అంటే BA వస్తుంది కదా, డైరెక్ట్ రాస్తున్నా సార్, BA minus AB sir, take minus common, then you will get AB minus BA. So therefore AB minus BA whole transpose equal to minus of AB minus BA. Therefore AB minus BA is skew symmetric. Is skew symmetric. So మన దీనికి ఒక పేరు ఉంది, ఏం సార్? AB minus B ఏమంటాం? సరే, if A is either symmetric or skew symmetric, then the matrix In minus A into In plus A is symmetric always. Is symmetric. In minus A into In plus A is always symmetric. అది ఏ అనేది either symmetric కావచ్చు లేదా skew symmetric కావచ్చు. Solution. Suppose let us assume that B is equal to In minus A into In plus A. So what is B transpose? B transpose equal to In minus A into In plus A whole transpose. Right, sir. So In minus A into In plus A ante In square minus A plus A, In into A plus A minus A into In is minus A plus minus into plus minus A square, sir. Whole transpose. These two are getting cancels. So then you will get In square is I minus A square. So then you can write whole transpose. So therefore which is equal to In transpose is In minus A transpose whole square. If it is skew symmetric, then A transpose equal to minus A square. So whole square equal to minus A whole square is nothing but plus A square. If it is symmetric, A transpose equal to A sir. Whole square equal to A square. In either cases, this value is equal to A square. So which is equal to In minus A square, which can be written as In minus A into In plus A. So A minus B into A plus B. So therefore, which is equal to B. So B transpose equal to B. Therefore B is equal to In minus A into In plus A is always symmetric. Is always symmetric. Next one. Which one of the following statements are true? Which one of the following statement is true? Options are statement 1, yes 1. A and B are A and B are 2 by 2 matrices. Such that AB minus BA, AB minus BA is equal to I2. AB minus BA is equal to I2. Statement 2. If A is skew symmetric matrix of order 3, then In minus A, In plus A is also skew symmetric matrix. And S3, if A is symmetric matrix of order n, then In plus A into In minus A is symmetric. Options are all. Option B, S1 and S3. Option C, S2 and S3. Option D, only S3. దీనిపైన చాలా సార్లు అడిగారు సార్. మొన్న రీసెంట్గా టీఎస్ సెట్ 2024లో కూడా అడిగారు సార్ దీని మీద. ఈవెన్ సిఎస్ఆర్ వచ్చింది ఈ ఈక్వేషన్ పైన. అంటే ఇక్కడ ఇలా అడుగుతున్నాడు, ట్రేస్ అని కానీ లేకపోతే ర్యాంక్ అని కానీ, ఇలా డిఫరెంట్ ఏబి మైనస్ బిఏ ఇస్ కాల్డ్ కమ్యూటేటర్. ఆల్రెడీ and also form state transformation, linear transformation like this. T of A is equal to AB minus BA. AB minus BA is equal to I2 అవుతుందా?
No, sir.
Suppose, if possible, assume that. If possible, AB minus BA, ఈ కింది అంటే మనకు తెలుసు, పైన ఇంతకు ముందే చేసి AB minus BA is equal to I2. So that means, assume that the trace of AB minus BA is equal to trace of I2. So trace of I2 and sir 2 kada, but trace of A plus B is equal to trace of A plus trace of B kada, which is equal to trace of AB minus trace of BA sir. Trace of AB is equal to trace of BA, but we know that since trace of AB is equal to trace of BA, so by this one substitute in this one, then you will get this value is equal to 0. 0 is equal to 2. Is it possible? Which is a contradiction. So therefore, AB minus BA is never equal to I2. is never equal to I2, sir. The trace of AB minus BA is always 0.